Welcome to another episode of BioLogic Science News. Today, I want to talk about some really bad news that comes from a recent study conducted by researchers in Germany. By placing insect traps at 96 locations across many of Germany's nature protection areas, the researchers studied seasonal airborne insect biomass over a 27-year period, from 1989 to 2016. The trend that emerged from their data was as alarming as it is ecologically destabilizing. Since 1989, there's been a huge decrease in flying insect biomass, especially during the summer season, with estimates averaging 76% biomass lost, and reaching as high as 82%. They also found that the biodiversity of the plant species, like the trees, shrubs, and herbs in the immediate proximity of their traps, had also declined. The plant richness had declined, quote, tremendously during the study's time period. What was interesting was that the study's authors didn't attribute this loss in insect biomass entirely to variables like habitat loss or climate change. In fact, those variables were taken into consideration, but they only account for some of the total lost biomass. They calculated that other factors like wind speed had negligible effect on insect biomass, while factors like temperature were positively correlated with insect biomass. The warmer it was, the greater the insect biomass there was. The rest of the missing insect biomass, the researchers believe, could come from another large-scale factor that would influence insect populations, like a prolonged period of low temperature or a lack of precipitation leading to a drought. Although the most likely factor responsible for this excessive loss in insect biomass is modern agricultural practices, specifically our use of insecticides. Across Western Europe, where the 27-year study was conducted, these nature reserves are just fragments of wilderness, surrounded on all sides by crop fields and agricultural plots. When farmers use insecticides, especially those with neonicotinoids, it disrupts some mechanism in the insect's endocrinology or cellular physiology, and it ends up killing them. We've seen this story time and time again, especially in the last 2 decades, as neonicotinoid use has increased on agricultural farms. These are used to keep the insects off the food crops, but the insecticide particulates can be carried along in the air. When these insecticides come into contact with insects like bees, they disorient the bee and make it lose its way home. So while the neonicotinoid doesn't outright kill the bee, it affects the bee in such a way that causes it to get lost and then die of starvation and exhaustion. A growing number of studies are implicating these neonicotinoid insecticides in the recent collapses in insect populations, like the recent mass bee deaths, the disappearance of the monarch butterflies, and the flying insect biomass that was documented in this study. Ever since their introduction to agricultural use in the 90s, we've been seeing these really startling trends as insect populations crash. The only areas on the planet that seem to be resisting this insect collapse are those extremely remote regions that aren't exposed to agricultural activity or pesticides of any kind. This study also showed that even protected areas, protected wilderness areas, are at risk if they're proximal to land that's being sprayed with pesticides. The solution to this problem, and it's a serious problem, is looking like it might ultimately end up being an extremely tight regulation or an outright ban on the use of neonicotinoids. The planet's insect populations simply cannot survive with them, and we need to sustain our insect biodiversity and our insect abundance far more than we need to keep using neonicotinoids. This is a serious issue that could have extremely destructive downstream ecological effects. I agree wholeheartedly with the authors of the study, who conclude their paper by saying, and I quote, "There is an urgent need to uncover the causes of this decline, its geographical extent, and to understand the ramifications of the decline for ecosystems and ecosystem services."